Hello everyone, and thank you for attending today's webinar, Apex 2.0 for EDS, What's New and Key Features. Before we begin, I'd like to cover a few housekeeping items. At the bottom of your audience console are several application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget and submit your question. We will try to answer these during the webcast, but if a fuller answer is needed or we run out of time, you'll receive an answer via email later. We do capture all questions. A copy of today's slide deck is available in the resource list widget that looks like a green folder. You can expand your slide area by clicking on the maximize icon in the top right or by dragging the bottom right corner of the slide area. If you have any technical difficulty, please click the help widget. It has a question mark icon and covers common technical issues. An on-demand version of the webcast will be available approximately 1 day after the webcast and can be accessed using the same audience link that was sent to you earlier. Now I'd like to introduce the presenter for today's webinar. Dr. Shengsheng Liu joined EDX in 2018 as an applications engineer. Working out of the Draper, Utah office, he is responsible for providing technical expertise, conducting demos, teaching training courses, and after-sales support. Shengsheng also performs testing and validation for the engineering department and provides support for the marketing team. Prior to EDX, Shengsheng was the lab manager at the Southeastern North Carolina Regional Microanalytical and Imaging Consortium in Fayetteville, North Carolina. Shengsheng graduated from Chengdu University of Technology with a Bachelor of Science in Material Science and Engineering. He earned a Master of Science in Material Science and Engineering from New Jersey Institute of Technology. Shengsheng completed his PhD in Earth Sciences at Boston University. Now over to Shengsheng.
Thank you, Jonathan, for the introduction. Hello, everybody. Welcome to this webinar. I'm very excited to introduce new and key features in Apex 2.0 software for EDS. Starting with an outline of today's talk, first I'll give an overview of Apex 2.0, introduce features for both EDS and EBSD. Then I will jump to EDS-specific features. I'll go through key features and new features on mapping and line scan, followed by new advanced quantitative methods we've added to Apex 2.0. Lastly, I'll talk about Spectra Match and Smart Libraries, which is an add-on, and give a brief summary of the software. Apex 2.0 is EDX's latest version of Apex software for integrated EDS and EBSD applications. It has grown considerably into a more complete microanalysis package since the introduction of Apex 1.5 as an entry-level system. This user-friendly 24-bit software ensures high-quality, accurate results and increased productivity with its easy-to-use user interface, lifetime graphical display, and simultaneous data collection and review capability. It comes in 3 options: Apex Suite, which is combined EDS and EBSD, Apex EDS only, and Apex EBSD only. So you have the option to purchase both EDS and EBSD or either one of them. The Apex 2.0 has an intuitive user interface. The most commonly used features are available on the ribbon bar. The icons use both graphics and text to describe functionality. Functions are organized into task-specific tabs, such as spectrum collection, line scan, and mapping to help the users to identify specific functions. Here I'm showing you the EDS spectrum collection ribbon bar in the top and review mode ribbon bar in the bottom. The workflow is very easy to follow. For example, the user can follow the icons on the spectrum collection ribbon bar to collect image, select points and areas to collect spectrum, change collection parameters and layout, and generate reports. While the most commonly used icons are available on the ribbon bar, and advanced settings can be accessed through drop-down menus. You can click on the little triangles circled in red to access those drop-down menus. From left to right, we have the detector settings panel. If you have a motorized slider detector, you can use it to insert or retract your detector. You can also set count rate and threshold settings to automatically retract the detector to avoid very high X-ray counts for an extended period of time. The next drop-down menus are Spectrum View and Advanced tabs. From here, you can change the preference for the element labels and ID sensitivity, enable or disable correction factors, and pile up consideration. I want to mention that the settings in live and review mode are decoupled. It means that one set of settings can be applied to live acquisition while using other settings to review data. The next one is spectrum collection parameter settings. You can change collection time, detector speed, or enable auto amp time. The last dropdown is Report Properties panel to customize your report, such as including a company logo, changing font size and color. Additional functions are provided through right-click menus. You can right-click on the image to send it to folder or save as multiple file formats. Right-click on Quant table can customize the items you want to display. Spectrum right-click menus give you the more spectrum display options, such as turning background and deconvolution on or off, change label sensitivity, font size, and spectrum colors. You can also access element ID options and spectrum file save options. Right-click on an element map, you can access map scaling, coloring, and save options. Click on a phase in phase map window can extract spectrum, combine phase, change phase color, and rename phases. The layouts are completely customizable. There are multiple preset layouts based on usage for each mode. Different view windows are available for each layout. The left picture shows the layout drop-down menu on ribbon bar for mapping. There are 5 layouts to choose from. The picture on the right shows the currently selected layout, which is Multimap View on right half, Spectrum window top left, and Image View window bottom left. All windows are detachable. They can be moved around, resized, floated, docked, tabbed, or moved to a secondary monitor. The custom layouts can be designed and saved. There are no overlapping or overloading of windows. For each mode, the user can set up to 5 custom layouts in addition to existing layouts. The custom layouts will be added to the drop-down menus marked in red box. You can have it their way, but grow and adapt as you learn. These are examples of custom layouts for spectrum, line scan, and mapping from left to right, top to bottom. In the bottom layout, we can see that the user is using a very large image window to see the overlay of line scan on SEM image. There are 4 color schemes available: light, dark, blue, and gray. You can choose the color you like, or have the color match your SVM user interface color. The dark mode can reduce your eye strain when you are collecting or analyzing data for a long time. Apex 2.0 is using HD5 data format. This is a self-contained file format. All of the data will be saved to a single project file. If you make any modifications to your data, everything will be saved back to the single project file. You can easily handle very large data sets and move things around. It allows for both easy sharing and the data transfer of full projects, as well as individual spectra and analysis results. This file format is also compatible with other software programs. Data management has been improved in Apex 2.0, so users can save data where they want. That means they can specify the drive and the folder location. They can name data what they want. So the names for both project file and the data nodes can be renamed. Users can move data when they want. So we use the single HDF files for organization and portability. Project tree format provides intuitive data organization. The default names can be renamed. Apex Review Mode and OIM Analysis provides remote analysis of EDS and EBSD data analysis away from your scope, respectively. There are many auto smart features available in Apex 2.0. Detector and collection parameters can be set automatically based on collection conditions. For EDS, amp time or the speed of the detector is auto-selected based on count rate. The duration for EDS mapping is auto-determined based on average counts per pixel. For EBSD, there are auto setup optimization for EBSD detectors and smart step size recommendations based on detector and magnification. The batch mode operation, this is a new feature added to Apex 2.0. With batch mode operation, sets of data at different stage positions can be collected as a batch operation. Once the collection in current field of view is done, the stage will move to the next field automatically for data collection. There's a batch list to manage these tasks. You can add or delete items in the list, save or import the list as well. Magnification, scan area, step size can be adjusted within the batch list. EDS specific parameters can be changed as well. The batch mode allows the user to easily set up different collection modes in different fields of view. This example shows different collection modes in 3 different fields of view. Within each field, you can do spectrum collection, light scan collection, and mapping altogether. To begin adding items to the list, just drag to your desired stage position, collect an image, draw a line, draw a spectrum area, or selecting a mapping area. Move the stage again, then collect a new image, then repeat area, line, or point selection. The items in the list will grow accordingly. With batch mode operation, you can do a one-time setup for all of the tasks. Click on the Collect button and walk away from the scope, or switch to Review mode to analyze your existing data at the same time. It allows you to more efficiently use your scope. We provide multiple advanced reporting functions. Reports can be generated as part of live collection or during data review. If you click on the auto report icon on the live collection ribbon bar, it will automatically add data to a report as soon as data collection finishes. Data from different areas can be sent to the same report. There are multiple templates to choose from for each collection mode. The report designer offers a wizard to create your own templates. You can design the layout, determine the items you want to include in the report, insert or complete a lab logo, change font size, and so on. Apex can be run as a single user interface environment where no logon is required, or as a multi-user system. In multi-user mode, access control can be through Apex or Windows authentication. Apex access control allows the administrator to create accounts for each user. If Windows authentication is enabled, you don't need to enter password to log on to Apex. It logs on with your individual Windows account. Nobody can access your data unless they have your Windows account password. There are user-specific settings available. The administrator or lab manager can set Apex state movement permissions for each user for additional safety. There are 8 languages available to choose from: English, Chinese, Czech, French, German, Japanese, Russian, and Turkish. It makes it easier to learn and use for users around the world. After setting a new language, restart the Apex software and the new language will take effect. We've added remote updates to Apex 2.0. The cloud-based updates enables timely distribution of the latest version. You can simply click on the check updates icon. If there are new updates available, they will be downloaded to your EDS PC, followed by installation. If internet connection is not available on your EDS PC, you can manually download the file and move it to the EDS PC to install. Apex 2.0 is 24-bit application and Windows 10 compatible. 24-bit applications can access more memory to handle collection of larger data sets, such as montage large area mapping for EDS and EBSD. It's built for Windows 10 operating system to meet the modern IT requirements and security requirements. Okay, moving forward, I'm going to introduce EDS specific features. Apex 2.0 for EDS is EDX's premier software for the collection and analysis of EDS data. As I mentioned before, Apex was introduced as entry-level software several years ago, but now we have added a lot of advanced features to this platform to make it available for both entry-level and advanced users. This is a list of features I'll cover, mostly mapping and light scan features and advanced quantitative methods. The first thing I wanted to talk about is it supports Octane Elite detectors, which is our high-end detector series. I mentioned in the very beginning that we have a control panel to insert or retract the motorized detector. You can also turn cooling on or off and set count rate and threshold to automatically retract the detector to avoid a long exposure to very high X-ray counts. Apex 2.0 for EDS features simultaneous live collection mode and review mode. While data is being collected in live mode, you can review and reprocess all types of data and produce reports. The two images give an example that you can collect a new map while rebuilding a different map you already collected at the same time. These two modes are decoupled, so they won't affect each other. With an offline license, you can install the review mode on your laptop and analyze the data you collected away from your scope. The lifetime spectral display with element IDs and quant values and charts allow easy data visualization and interpretation. You can add the columns to show in Quantitable and apply filters to the Quant results. Element composition is available as pie charts, 3D pie charts, and histograms. You can also overlay multiple spectra together and use statistics display to show data from multiple spectra simultaneously. There are some tools to show the maximum or minimum number, average number, and median number of multiple quant results. Drift correction is available in all of the collection modes. That means spectrum, line scan, and mapping modes. You can enable drift correction in just a single click. Drift parameters will be set automatically for easy operation. Correction frequency is dynamically adjusted based on the drift magnitude. You can easily toggle the drift correction control panel on or off to see the correction data and access more options. The panel shows the field of view, reference, and current images for the data set being collected. The location of the drifting sample is shown on the graph as well as in the data tables through XY offset coordinates and their corresponding time. You have the option to save drift image, and you can manually define a reference area for drift correction. Combined with current generation EDS detectors, you can do fast mapping with high throughput and high resolution. The M time, also called time constant or process time, ranges from 0.12 microseconds to 7.68 microseconds. You can use the slider bar to adjust M time if manual quality is enabled. At the slowest M time, 7.68 microseconds, the resolution is about 125 EV, which is very high. Even if I use the fastest M time at 0.12 microseconds, the resolution is still below 150 EV, which is not a significant decrease in resolution. So fast M times can ensure high throughput while keeping very good resolution. These two pictures show maps collected at over 400 key throughput counts with fast M time. On the left, 1 frame 11-second mapping gives you a nice overview of the element distribution in the sample. Variation in concentration and phase separation are nicely shown in individual element images. On the right, high-quality element maps are done in just 1 minute. By the way, our M times are not arbitrary numbers. They have true physical meanings. The amp time is the actual time measurement of the rise time or fall time of the X-ray pulse, so you know how fast your detector can run exactly. You also have the option to use auto amp time. In this case, the amp time will be selected based on count rate. In Multimap View window, you can see all maps in one window for quick evaluation. You can zoom in and out individual maps. To the right of each individual element map, the sliders along the intensity bar allows the user to define a low and high threshold in a histogram to extract the spectrum from or adjust the contrast of the map. These functions can be easily accessed through right-click menus. You can also select multiple maps to have them overlaid in the larger imaging view window. The picture on the bottom left shows iron and oxygen are overlaid on top of magnesium. Another thing I want to mention is the grayscale map in the top left corner of the Multimap View. This is a CPS map, or counts per second map. It shows the X-ray count rate at every pixel. The brightest pixels indicate the highest count areas, and the dark or black areas indicate little or no X-ray counts. It is a quick and easy check of the variations in count rate across the sample area. You can see that there's a dark region in the center. That means there's a crack on the surface with very low intensity of X-ray counts. The variations due to topography can be compensated by applying a CPS normalization to the element maps. The map element colors can be changed. You can click on the element colors icon on ribbon bar to open the periodic table to change map element colors. The colors can be changed before starting the map, during a map, or after mapping. There are 40 colors to choose from. Dynamic element mapping is an advanced mapping feature. In live connection mode, elements and user-defined energy regions can be added or removed in the spectrum window on the fly. You can simply click on an energy line and the candidates will show up. To remove an element, just hover over the element label and click on Delete. Once the modification is done, click on the Refresh button in top right. The number of element maps will be adjusted accordingly. New element maps will show up in the Multimap View window automatically, and you don't need to manually delete the element maps from the window. Combo Maps is the live map mapping feature. I want to give you a little background information about mapping. The most common map representation is ROI, or region of interest, due to the simplicity of generating images. The idea is for each X-ray line identified, a region of interest is defined. The counts within the given region of interest are summed for each pixel and used to assign a brightness level to the pixel, which is then plotted in the map. A significant limitation for ROI maps is the background contribution and overlapping regions for X-ray lines that are close in energy. Net maps are often used to avoid the shortcomings of ROI maps. The live map mapping does a live background subtraction and peak deconvolution during mapping to separate maps from overlapping peaks. You can click on the net icon to activate it and toggle between ROI and net at any time during mapping. The example I'm showing you here is phosphorus K and zirconium L. These two peaks are heavily overlapped with only 29 eV of energy difference. This sample contains phosphorus and zirconium in separate phases. Those are calcium phosphate and zirconium silicate. The top row maps are region of interest. You can see the phosphorus K and the zirconium L maps are almost identical because their ROIs are heavily overlapped. But once you toggle to net maps as shown in the bottom row, the phosphorus K and zirconium Ls are separated out. The overlapping peaks are resolved by background subtraction and peak deconvolution. The larger image on the right is an overlay of phosphorus K on zirconium L. You can see that they exist in separate phases. In a review mode, maps can be rebuilt into ROI, net, or ZAF, weight percentage, or atomic percentage. You can add or remove elements before the rebuilding process. So if you missed some elements during live mapping, you can always add them back to map rebuild. ROI is the raw map, net map is background subtracted and peak deconvoluted map. For quant maps, a full quantification routine will be run in every pixel, and the maps are shown in weight percentage or atomic percentage. With the scales to the right of the quant maps, you can estimate the concentration based on color intensity. The spectrum shown in mapping mode is a sum spectrum. The sum spectrum is very useful for identifying the primary elements in the sample, but tends to hide inclusions that only make a small contribution relative to the primary matrix. A maximum pixel spectrum can be built to identify small inclusions and particles by finding the pixel with the highest number of counts for each point on the energy axis and using that as the intensity for the processed artificial spectrum. In the picture below, the green outline is the maximum pixel spectrum overlaid on the sum spectrum in red. You can see the maximum pixel spectrum is noisy because each data point is based on a single pixel, but it highlights elements that are below the signal-to-noise ratio in the sum spectrum. And from this green outline, you can see there are a bunch of peaks missing in the sum spectrum now show up in the maximum pixel spectrum. For example, it shows silver, which is hidden in the sum spectrum. The picture is kind of blurry, but we have the silver peak sticking up, and we don't have this peak in a sum spectrum. Because a full spectrum is saved at each pixel, the maps can be rebuilt to include the previously undetected elements. With the information from previous slide, now you can include silver to rebuild the map to see where it is. The middle image is a rebuilt silver L map. You can see there's only a little spot of silver. Probably it's from a drip of silver paste during sample preparation. So this is the idea that how you find small inclusions or particles in your sample, though the maximum pixel spectrum is noisy, but it's useful. The Smartphase mapping is very powerful. This routine will separate areas of the sample that have similar composition by comparing relative peak heights and color code them accordingly. To do this, the routine looks at ROI counts of the identified elements and applies a background subtraction. It then compares the count ratios of the peaks pixel by pixel and group them by a chi-square goodness of fit. The right half of the user interface is the phase map view window. You can click on a phase from the list to see element maps of this phase. There are advanced functions such as phase library toolbar, phase right-click menu, tolerance and adjustment button. They are circled in red. I'll introduce them on the next slide. The top image is phase library toolbar. If auto discover is checked, phases will be determined automatically during EDS mapping. You also have the option to load a spectrum or extract a spectrum from a mapping area to save them in phase libraries for matching. In the middle is the phase right-click menu. You have the option to extract selected phase spectra, combine two selected phases together, select a phase color, and rename a phase. In the image, I renamed the red phase, it was silicon oxygen phase. I renamed this to quartz because it's from a rock sample. The bottom image is the tolerance and adjustment button. You can adjust phase classification thresholding for complex materials. In other words, it adjusts how different the relative count ratios should be before a new phase is added. Turning the knob will adjust the tolerance between 0 and 2. Click on Reset will reset the tolerance to the default value. Basically, this Smartphase map, this tolerance knob controls the number of phases identified. Montage large area mapping. This is a major new feature in Apex 2.0. It uses stage movements to map multiple fields of view and automatically stitches the maps together into a single file for comprehensive analysis. The Apex software will take control of the stage movements, so you don't need to manually move the stage to the next field of view. The example I'm showing here is an entire 2.5 by 1.5 centimeter geological section. This was acquired by Montage Large Area Mapping. It consists of 24 by 27 fields of view. The full resolution montage map can be saved to your local drive by right-clicking the map and select the corresponding function. It features an easy-to-use setup wizard with step-by-step instructions. It will guide the user to move the stage to the starting position to collect the top left image, and then to the ending position to collect the bottom right image. When the images are collected, the number of fields will be automatically calculated, and a graphic representation of the montage will be shown in a grid layout. The user can move the position marks at the top left and the bottom right of the images, which are the little green circles, to adjust the starting and ending positions, and the number of fields will be recalculated accordingly. The preview image function will go through the montage and collect an image of each field. Matrix size, dwell time, and frames can be adjusted to complete the setup wizard. The time duration estimation and required disk space will be updated accordingly. After this setup wizard is finished, you can just simply click on the connect button to start the mapping process. In Apex 2.0, we've added live quant for light scan collections. It allows the user to collect live net atomic percent or weight percentage light scan data. You can click on the drop-down menu on ribbon bar to select the type of light scan collection. The live display will show the quantitative or net intensity numbers as an overlay directly on the top of the image. You can make the numbers along the axis larger and choose a different color. Light scans can also be rebuilt as net weight percentage or atomic percentage in the review mode. So this review mode light scan rebuild was available in the previous Apex version, but live quant for light scan is a new feature. We've added a bunch of advanced quantitative methods to Apex 2.0. They include flexible background modeling. You have the choice between two quantitative models. We have carbon coating corrections. We added Oxide Results. We added the customizable scaling factors, SCC and SS, and it has automatic calculation of the minimum detection limit. For background modeling, the user can choose between Brimstone background and Snip background. The two pictures shows the difference between the two background models. The top one is Brimstone. We can see the background is with steps. So those steps are absorptionized. In the bottom, the Snip mode, the background is a smooth curve. The Brimstone background model is a full physics model. It takes the entire geometry and composition of the sample into account. If the fit is bad, it usually indicates deviations from assumed geometry. So it's an indicator that do not do quant. Otherwise, the quant results will be bad because your sample does not satisfy the assumptions of quantification models. This model includes information about tilt, self-absorption, electron artifacts, and it also allows the use of peak-to-background models. The Snip model, this is a pure mathematical filter. It has no user input. It always gives you constant results. It gives a good fit regardless of geometry and sample surface. It works very well for qualitative assessment of your samples, especially for non-ideal samples such as fracture surfaces, tilted samples, and particles. It always separates peaks from background very well. In addition to the traditional ZAF quant model, we have peak-to-background ZAF quant model to choose from. The main difference to the classical ZAF model is the primary data input for weight fractions calculations. So for the peak-to-background model, not only the measured net counts of characteristic radiations are evaluated, also the measured Brimstone background of same energy. So that means we calculate the peak-to-background ratio. We know the traditional ZAF quant model doesn't work quite well on rough surfaces. because there will be additional attenuation of X-rays on the surface that cannot be predicted by the Quant model. For peak-to-background VAS model, since the characteristic peaks and the background will be attenuated by the same amount, so the peak-to-background ratio will essentially be unaffected. So the peak-to-background approach is nearly eliminating many the major effects of X-ray absorption in specimen and the detector. That means that this model is recommended for particles, rough surfaces, and fractures, as it is less sensitive to topography effects. An additional benefit of this approach is because we are using the ratio, so the beam currents in numerator and denominator of the equation are canceled out. It means this is a standardless, non-normalized quantification routine. This is also a good sanity check for Quant. Since it is non-normalized, the results should add up close to 100% if everything is well. For example, if the sample is flat, conductive, it's a bulk sample, and so on. If the results deviate from 100%, it could indicate misidentified elements, geometry offsets. For example, the sample is not aligned with the stage. It could indicate backscatter electrons, charging effects. The spectrum I'm showing here, this is a steel sample. I have nickel peaks, which are major peaks unlabeled on purpose. The peak-to-background ZAF Quant, it shows the total is only 24.8%. That means some major elements are missing. If you add nickel back, it will be close to 100%. In contrast, for the column of VAF Quant, in this case, it will just bump up the chromium, manganese, and iron a lot to make them add up to 100%. So the missing element is hidden. If this model is so good, we can use it all the time, but the drawback of this method is that the routine relies on the background being correct. Attention must be paid to the background model. So generally, the peak-to-background approach also requires better statistics to obtain good results. That means longer acquisition times. And it is not applied for elements with X-ray energies below 1 keV, because in the very low energy region, we have a very high background, the ratio is low, and we have high absorption in that region. The customizable scaling factors, it includes two factors. SCC is for the traditional VAS Quant model, and the SF is for the peak-to-background VAS Quant model. So the factors allows for the optimization of the quantification models for specific samples and applications. Let me give you an example. When mineralogists look at iron in inclusion, they have to reduce KV to use iron alloy. Iron L peak height depends on binding configurations. Iron L in steels or in oxides give very different peak heights with the same concentration. When our model do first principle calculation of electron-excited photons for iron, so this is an important parameter in the quantification model, we just do the average. This is what we think is the best for most applications, not necessarily the best for minerals or steels. So if you want to tweak the model up for minerals, you can calculate the SCC factors specifically for minerals. Calculation of this factor is done by measuring a single element reference sample followed by samples of known composition for the elements that are to be optimized. It also comes with the benefit that the use of a reference measurement allows for non-normalized standardless quantification. To summarize the benefit of SCC and SF factors, first of all, it optimizes the calculation in the model to get the right results for specific samples and applications. And secondly, you can do quant non-normalized without standards. The minimum detection limit, basically it looks at the statistical significance of the signal above background. The requirement for an element to be considered significant is the total count on the peak is above background count by a predetermined confidence. Elements that are found to be below the detection limit are flagged in the quantification table. Carbon coating corrections comes with 3 options: auto, manual, and calculate. You should use auto if your sample does not contain carbon, then it will auto calculate the carbon coating thickness. The thickness is based on height of carbon peak in spectrum. Manual is used when you know the thickness of carbon coating. If your sample contains carbon, carbon from coating will be deducted from the Quant results, and the carbon weight percentage will be adjusted accordingly. Calculate is used to calculate the carbon coating thickness from the spectrum displayed. A kind of tricky situation is sometimes you need to analyze a sample that contains carbon, and you need to know the thickness of carbon coating. In this case, you can carbon coat this sample and a sample without carbon together. Then you collect the spectrum from the sample without carbon and click on the Calculate button to calculate the carbon coating thickness. The same thickness can be applied to the sample that contains carbon. So when you analyze the sample with carbon, you can use this method to figure out the carbon coating thickness and manually type in the thickness in the box. Oxide Results option is added to Apex 2.0. With this option, you can easily switch between element results and oxide results. When it is enabled, the individual elements will be shown with their corresponding stoichiometry, and oxygen will be shown as 0 weight percent. There are some applications that don't want oxide to be measured. For example, mineralogists usually don't measure oxygen directly. They would like to have the Quant results shown as oxides, and oxygen is calculated based on stoichiometry. By the way, you must have oxygen identified before using oxide results. Spectrum Match and Smart Libraries, this is an add-on to Apex 2.0. This is a quick and convenient method for identifying compounds present in a material. A user can conclusively identify a material without relying on data interpretation. This is a good tool to have for doing something over and over again. So basically, any data on the system can be searched and included in the library. You can delete or add data to a library, combine multiple libraries together. The software matches a collected unknown spectrum to a library of different spectra, and the libraries can be shared between labs and sites for multi-system users. There are two matching methods available. Chi-square on concentration method, it allows different KV and conditions. So that means spectra collected at different KVs or collected by different detectors. You can also use spectrum match. Chi-square on spectrum method doesn't depend on any peak ID or quant results. So the software will compare the spectrum channel by channel. It allows analysis even on dirty contaminant or not pure samples. So it works for the real-world samples. The spectrum matching panel is very easy to use. You can search through data on the system to create a library or load an already created library. Choose a match method and adjust the match sensitivity. Lastly, just click on the match button to see the results. The top three matches are displayed with numerical values of fit percentage. Spectral overlay confirms the details of spectral peak fit. Spectrum match is very useful, for example, for contaminant analysis. If you need to identify a bunch of contaminants from unknown samples, you can collect spectra from these contaminants first and build a library. Then you can run spectrum match to compare unknown samples to the library. It will tell you what it is instead of doing quant and compare how close are those numbers over and over again. The Smart Materials and Minerals library, this is an add-on including 150 entries of common metals, standards, and minerals. Okay, to summarize, the Apex 2.0 features intuitive and user-friendly user interface. It's completely customizable. It has completely customizable layouts. It has multiple preset layouts. You can have it their way, but grow and adapt as you learn. It features simultaneous data collection and advanced review mode analysis. It has improved data management and advanced reporting. It has a bunch of auto-smart features to help you to collect high-quality data easily. It has batch mode operation for efficiency, easy to use drift correction, a bunch of advanced mapping features, and an advanced quantitative method. The spectral match can do unknown identification quickly and conveniently. Okay, so there are some additional resources. Just want to make sure you are aware. We do webinars on a regular basis. So this is a link to our webinar site. Please always check back. We have a lot of good recorded webinars. You can watch them on demand. We have blog posts about our products and applications, including some very interesting stories. And we have movies on YouTube. And please follow our social media. If you have any additional questions, feel free to give us an email. Okay, now I'll go into the Q&A session. Okay, there are a lot of questions. I will answer a couple of them, and because the time is almost up, but all of the questions will be answered. I will get back to you by email. Okay, the first question is it always better to collect maps using net instead of ROI? And the answer is yes. The net mapping is always better than ROI. The net mapping does background subtraction and peak deconvolution, but it requires more calculation. So some of the systems does not feature the live net mapping. So if you have this option, it's always good to use net mapping, because the region of interest mapping, they are just purely count-based. There are no background subtraction and peak deconvolution. Net mapping is kind of computation intensive. Okay, the next question is what will happen to team software? It is gonna be stopped because of the Apex has all of the team capability. Right now, Apex is an advanced package. Most of the features in team are available in Apex. But the team has Quant with standards. Team has PEM capability, and the team has WDS support. So right now, we are still using team, but eventually the Apex will take over team. And so you can upgrade from team to Apex. And just be aware that a lot of the team upgrades would require a PC upgrade as well. And so please go through our service department for configuration check if you are interested in this upgrade. Okay, the next question. The labeling of the spectra looks very long. Is it possible to label a spectrum with a short description like sample ABC? Yes, you are able to rename the label of the spectra. Basically, you can rename the project file, the nodes, the sample area, the sample name. So a lot of things can be renamed. Okay, time is almost up. I will conclude the webinar right now. Well, thank you for joining us. Have a good one.